Welcome to Vinuta's Math channel. In the last class, we were discussing about a memory. In that, we were discussing about a primary memory. Basically, a memory it is nothing but a memory consists of large number of semiconductor storage cells. These storage cells will be having a capability to store one bit of information, and to process these the informations will not be uh, considered by bit, it will be considered a group of bits. Okay, so those group of bits which are considered at a time for one basic operation, those are called as a word. We had taken an example of in a 32-bit processor, for each basic operation or for one basic operation, a 32-bit can be stored once or it can be retrieved. Okay, so next we will take the concept of address. Address, it is nothing but these are the numbers which are given to the memory locations to identify them. Okay, let us consider we are having, this is our memory block. Okay, so to identify the first block, some number has been assigned to it. To identify the second block, some number is being associated with it. Okay, so those numbers which represents this first block, second block, third block and so on in a memory, these are called as a address. Okay, why it is being done? It is to give an easy access to a word in a memory, to save or to retrieve any information from the memory. The number of bits in each word, it is called as a word length, and the programs must reside in a memory during execution. During execution of any program, the program must reside in a memory. Okay, instructions and the data, it will be taken into the memory and read out under the control of processor, meaning the informations, the instructions and the data, this must be stored in a memory while performing any operations. The operations will be controlled by a control unit. One second. Next, what is a random access memory? A random access memory is nothing but it's a memory in which any location which can be reached in short and fixed amount of time, meaning primary memory. It is called as, you can access a memory which is at a faster rate in short duration of time. That type of memory is called as random access memory. The time required to access one word is called as memory access time. Okay, the time which is required to one word, the time required to access a one word. Okay, if we consider this as a memory to retrieve any information from a memory from one block, the time required, it is called as a memory access time. Okay, the memory which is only readable by a user and the contents of which it cannot be altered, these are called as read only memory. There is one memory called read only memory. Here we cannot alter any information or any program. It will be in the state of readable. We can't do any changes or we can't write anything. This memory is called as read only memory. In ROM, it mainly consists of an OS, operating system. Okay, next, the caches. Cache is nothing but in the next diagram I'll explain about the cache. These are nothing but these are the small and fast RAM cells. These are coupled with the processor. These cache cells, these will be coupled with processor, and these are contained on the same IC chip. Why it is contained on the same IC chip? To achieve an high performance. Okay, it is very essential and it is also very expensive, the cache. The second type of memory is the secondary memory. The secondary memory, this is used when large amount of data and the programs needs to be stored, then only this secondary memory will be used. Okay, what are the examples? The magnetic disks, CDs, floppies. Nowadays we are using pen drives. Now coming to the arithmetic and logic unit, it is the most of the computer operations that are executed, that will be performed in ALU, that is the arithmetic and logic unit. Here what are the operations will be done? Operations like addition, subtraction, division and multiplication. Okay, coming to the operations of ALU, the operands will be brought into the ALU from a memory, meaning the operands, if I take an example of A plus B, the operands A and B, this will be taken from a memory and it will be brought into an ALU unit or a processor, and these will be stored in an high speed storage elements. These are called as registers. In a processor, high speed elements are there, that are registers R0, R1, R2, so on up to Rn minus 1. Here these operands will be stored to do any operations. Okay, and then according to the instructions of the operations, the operation will be performed and the result will be stored. Okay, next, the control of ALU is many times faster compared to other devices connected to it, meaning input output devices. Compared to these operations, the ALU operations are many times faster. Coming to the output device or output unit, these are nothing but these are the display units. These are counterparts of input units. Okay, the basic function is to send the processed result to an external world. What are the output or devices or the units? The printer, speaker, monitor, these are the output devices. Now what does the control unit does? It effectively, it is nothing but it's like a brain which connects to the all parts, or it coordinates the working of each and every unit of a basic computer. It is a nerve center that sends an information to other units and senses their states. Okay, whether it is in read state or write state. Next, coming to the basic operational concepts. Till now we discussed about the functional units, basic functional units of a computer, that are five functional units are there. Okay, we have discussed about that. Now we will look into the basic operational concepts. To perform any given task, a program which will be consists of an instruction. Okay, to perform any operations, an instruction is important. In this example, add is an instruction. Okay, this instructions, it will be stored in a memory. These instructions will be there in a memory. To perform any operations, these individual instructions which are there in a memory, let us consider this is a memory and this as a processor. Okay, the instructions will be there in a memory. To perform any operations, these instructions must be taken into the processor to perform any operations. Fine. To perform any operations, even we need a data also. See in this example, add LOCA comma R0. LOCA means location A. Okay, location A comma R0. So this LOCA, it is nothing but it's a address of some memory. So we need those contents of LOCA into the processor and the contents of R0, these must be added. Okay. So what does this example says? Add LOCA comma R0. It means the contents of LOCA. Let me consider the LOCA it as a first block. Okay. This instruction is saying to add the contents of this. For example, let me consider the number 5 is there in this LOCA. I have to add this 5 with the contents of R0. R0, where it will be there? I'll show in the next diagram. It will be there in a processor. Let me consider R0 is here. In this R0, 3 is being stored. Okay. So it is saying add the contents of LOCA, that is 5, with the contents of R0, that is 3, and keep it in R0. Okay. So 5 plus 3, which is equal to 8, where it has to be stored? In R0 itself. So the contents of R0 will be updated with 8, whereas the contents of this cell memory LOCA, it will be remain with 5. Understood? Okay. Now let us coming to the steps. I have already told you about these steps. The first step is the instruction is fetched from a memory into the processor. That is the add which was there in a memory. It will be fetched into a processor. Next, the operand at LOCA is fetched. That is LOCA. It is nothing but the contents of the memory. The memory address here it has been represented as LOCA. It is fetched and added to the contents of R0. The contents of R0, to that it will be added, and finally the result is stored in R0. Okay. So this instruction what I have shown here, this instruction, that is add LOCA comma R0, even this can be replaced by these two operations, that is load LOCA comma R1 and add R1 comma R0. Okay, even we can perform the same operation by these two steps. So okay, so the operations what we had told in the earlier stage, that is add LOCA comma R0, that can be replaced by these two instructions. Here in these two instructions what it is telling, load LOCA comma R1, that is this instructions indicates to load the contents of LOCA. LOCA meaning it is a memory. The contents of this memory is to be stored in R1. R1 it is nothing but it's a general purpose register R1, and in the next instructions it is telling to add the contents of R1 and the contents of R0. That result must be stored in R0. Okay, the last by the last information what here we have mentioned, this is a destination. Okay, so add the contents of R1 with the contents of R0 and store it in R0. The same operations will be done even by this instructions. Now we are telling about we want the data from the memory to be from the memory to the processor, right? In all our previous example we are telling we have taken a data or an instruction from memory to the processor. How it will be done? This will be done by the transfer between a memory and the processors. These are started by sending the address of the memory locations, it is to be accessed to the memory unit and issues the appropriate control signal. Okay, meaning, for example, let us consider it as a memory and it is a processor. If I want to access the contents of this part of a memory, let us consider this part of a memory with an address 0000. Okay, so a processor, this will send, this is a processor and this is a memory. This processor will send the address, this address, to the memory, and it will send a appropriate control signal. For example, if it wants the contents of this location, it will send a read signal. Okay, it will send, the processor will send the address as well as a read signal. Then after issuing the contents of this memory, okay, the contents in the memory location 0000 will be read, and that contents will be stored in a register, for example R0, R1, whatever. Fine. Now the next is an connection between a processor and a memory. How the memory is being connected with a processor. Okay, so this figure shows the connection between the processor and a memory. This is a memory. This is MAR. MAR meaning memory address register. This is MDR, memory data register. This is a control. PC. PC meaning program counter, instruction register. Okay, these are the general purpose registers R0 to Rn-1. What is N? N is nothing but the number of bits in a word. If for example we are considering 32 bits, 32 bits of information it could retrieve at a time. In those cases R0, R1 up to Rn-1, so till R31. Then this is a control and ALU, arithmetic and logic unit. This whole box indicates a processor. Okay. Now if this is a memory and this is a processor, in this memory, okay, in this memory we want to access the location 0. Let me consider this address of this location as 0000. Okay, while writing it has become 6, but I am taken it as 0000. Okay, in this content the number 3 is being stored. So to access this information, to read the contents of this 0000, an control signal will be sent from a processor. See here, there is a processor, here is a control. So this processor sends a control signal. What the operations I want? I need the contents of this location to be read. Okay, so the control signal read will be sent to here, and then it will send the location also. What is the address of that location? 0000. So this 0000 address, it will be sent to MAR, memory address register. So the memory address registers holds the address of the memory. Okay, so this will be sent to the memory. Now in a memory, after receiving this MAR address and the read signal, what this memory will do? It will go to this memory location and it will fetch the contents of this. What is there in this 0000? 0000, it is 3. So the number 3 will be loaded to the MDR. MDR is memory data register. Okay, so this MDR, it will be loaded with 3. So we got the contents in a memory to the processor. I think all have understood this concept. Here I have given about what is an instruction unit, instruction register and all. Instruction register, it is nothing but it holds the instructions that are currently being executed. The instructions which is to be executed, that will be held in an instruction register. Next, the PC, that is a program counter. Program counter, this keeps track of the execution of program. The next instructions to be executed, that will be stored in PC. And besides this IR and PC, we are having the general purpose registers R0 to Rn-1. Okay. So MAR and MDR I have already told. MAR is nothing but memory address register. It holds the address of the location to be accessed. MDR, it contains the data to be written or to be read out of the addressed location. Okay, I guess you people have got a basic idea about how the connection is being established between a processor and a memory. In the next video, let us consider one example and we'll look into the operation steps. Okay, if you like this video, hit a like button and do comment your opinion in the comment box. Subscribe to our channel, and even we are having a Telegram group. Join there and your each and every query will be addressed. Thank you for watching. Happy learning.